Picture this, a volcanic eruption so massive it could swallow entire countries. Now imagine witnessing it from space, on a moon 400 million miles away. Welcome to Astronomy Daily, where today we're bringing you the most explosive story from Jupiter's volcanic moon Io. Literally, I'm Anna.
And I'm Avery. Anna, when NASA's Juno spacecraft captured the largest volcanic eruption ever seen on Io, it reminded me why we explore these distant worlds. The sheer scale of what's happening out there is mind-blowing.
Absolutely. And speaking of exploration, we've also got some groundbreaking news about nuclear propulsion that could revolutionize deep space travel. Plus, discoveries about ancient Martian beaches, the communication networks keeping Artemis astronauts connected around the moon, a lunar world tour happening in February, and fascinating research about life's ingredients forming in space. It's Friday, January 30th, 2026, and you're listening to Astronomy Daily.
Let's get into it then.
Avery, let's dive right into this spectacular volcanic eruption on Io. NASA's Juno spacecraft has been giving us unprecedented views of Jupiter's most volcanically active moon. And this latest discovery is absolutely stunning.
It really is, Anna. During Juno's 71st close flyby of Jupiter on January 28th, the spacecraft captured what scientists are calling the largest volcanic eruption ever observed on Io. We're talking about a plume that's absolutely colossal in scale. The plume was spotted at a volcano called Kanehikili. And here's what makes this so remarkable. The plume extends an estimated 240 kilometers, or about 150 miles above Io's surface.
That's incredible. To put that in perspective for our listeners, that's roughly the distance from New York to Philadelphia. But instead of a road trip, we're talking about a volcanic plume shooting straight up into space.
Exactly. And what makes Io such a volcanic powerhouse is the immense tidal forces it experiences. Jupiter's massive gravity, combined with the gravitational pulls from its sister moons Europa and Ganymede, literally flexes Io's interior, generating enormous amounts of heat. It's like continuously kneading dough, but on a planetary scale.
The images Juno captured are fascinating too. Scientists used the spacecraft's JunoCam instrument, and what they saw was this enormous umbrella-shaped plume extending from Kanehikili. Scott Bolton, Juno's principal investigator from the Southwest Research Institute, described it as both enormous and incredibly faint, which is why these observations are so valuable.
Right, and this isn't just about impressive visuals. Understanding Io's volcanism helps us learn about tidal heating processes throughout the solar system. Plus, Juno has been on quite the journey. The spacecraft has made 18 close flybys of Io since entering Jupiter's orbit back in 2016, and it's scheduled to continue observations until at least 2025.
Actually, Avery, we're now in 2026, so Juno has been extended beyond that original timeline, which is fantastic news for continued observations. This discovery really highlights how active and dynamic Io remains. It's not just the most volcanically active body in our solar system, it's constantly surprising us with the scale of its eruptions.
Absolutely. And there's something almost poetic about witnessing such raw primordial forces at work on another world. While we deal with our relatively tame volcanic activity here on Earth, Io is experiencing eruptions that dwarf anything in our planet's history.
It's a powerful reminder that our solar system is far from a static, quiet place. There are worlds out there where the geology is extreme beyond our everyday comprehension. All right, let's shift gears from volcanic fury to the cutting edge of space propulsion technology.
Anna, if we're going to send humans deeper into the solar system, to Mars and beyond, we need better propulsion systems than what we currently have. That's where nuclear technology comes in, and NASA just achieved a significant milestone.
This is exciting stuff, Avery. NASA and the Department of Energy recently fired up Krusty, and yes, that's actually the acronym they went with, which stands for Kilopower Reactor using Stirling technology. This test represents a major step toward making nuclear power a reality for deep space missions.
I love that acronym, but beyond the fun name, this is serious technology. Krusty is a small fission reactor designed to provide reliable power in the harsh environments of deep space. We're talking about a system that could generate around 10 kilowatts of electrical power continuously for over a decade.
10 kilowatts might not sound like much compared to a power plant, but in space, it's transformational. That's enough to power life support systems, scientific instruments, and habitats on Mars or the Moon. Traditional solar panels become less effective the farther you get from the sun, but nuclear reactors work anywhere.
Exactly, and the technology behind Krusty is elegantly simple in concept, if complex in execution. It uses a solid uranium core about the size of a paper towel roll. Nuclear fission in this core generates heat, which is then converted to electricity using Stirling engines. These are highly efficient engines that convert heat to mechanical energy and then to electricity.
What I find particularly impressive is the safety engineering. These systems are designed to be inherently safe, with passive cooling systems that don't require active intervention. During the Nevada test, engineers put Krusty through its paces, simulating various failure scenarios to prove it could handle extreme conditions.
Right, and this isn't just theoretical anymore. The successful test demonstrates that the technology works. Now, NASA is looking at scaling this up for actual mission use. Imagine a Mars base powered by one or more of these reactors, providing consistent power regardless of dust storms, nighttime, or seasons.
It also opens up possibilities for missions to the outer solar system. Places like Titan or Europa, where solar power is essentially useless, suddenly become more accessible with reliable nuclear power sources. We could have rovers or even submarines exploring these distant worlds.
And let's not forget about nuclear thermal propulsion, which is related but different. That's where nuclear reactors heat propellant to generate thrust, potentially cutting Mars transit times in half. Between power generation and propulsion, nuclear technology could be the key to humanity becoming a truly spacefaring civilization.
It's one of those technologies that sounds like science fiction, but is rapidly becoming science fact. The Krusty test proves we have the engineering capability. Now it's about implementation and integration into actual mission architectures. Speaking of missions, let's head to Mars, where scientists have discovered intriguing evidence of ancient water.
Anna, one of the biggest questions about Mars is whether it ever had conditions suitable for life. Every time we find evidence of ancient water, we get closer to answering that question, and this latest discovery is particularly compelling.
It really is, Avery. Researchers have identified what they believe to be ancient beach deposits in Mars' Gale Crater, where the Curiosity rover has been exploring. These aren't just random rocks. They're sedimentary layers that tell a story of water lapping at ancient shorelines billions of years ago.
The evidence comes from detailed analysis of rock formations that show characteristics consistent with beach environments. We're talking about specific grain sizes, layering patterns, and chemical signatures that match what we see in coastal deposits here on Earth. The team identified features like ripple marks and crossbedding that form when waves and currents move sediment.
What makes this discovery particularly significant for habitability is that beach environments on Earth are incredibly productive ecosystems. The interface between water and land, where you have tides, nutrients washing in, and varying conditions, creates opportunities for diverse life forms.
Exactly. If Mars had stable shorelines billions of years ago, those would have been prime locations for any potential Martian life to emerge and thrive. You've got water, you've got minerals being concentrated, you've got energy from the sun, all the ingredients that life needs.
The research also helps us understand Mars's climate history. For beaches to exist, you need a stable body of water over extended periods, not just brief flooding events. This suggests that ancient Mars had a more Earth-like hydrological cycle than we might have thought, with lakes or seas that persisted long enough to create these coastal features.
And the location in Gale Crater is significant too. Curiosity has been slowly climbing Mount Sharp in the center of the crater, and as it climbs, it's essentially reading through Mars's geological history like pages in a book. These beach deposits fit into a broader narrative of a wetter, warmer ancient Mars.
The implications for future missions are huge. If we can identify ancient beaches and shorelines, those become high priority targets for searching for biosignatures, chemical or physical evidence that life once existed. We might want to send future rovers or even sample return missions to these locations.
It's also worth noting how far we've come in our understanding of Mars. From a planet we once thought was completely dry and dead, we now know Mars had rivers, lakes, possibly oceans, beaches, and deltas. Each discovery adds another piece to the puzzle of what ancient Mars was really like.
And who knows, maybe one day humans will walk on those ancient beaches 4 billion years after waves last touched them. But before we send humans to Mars, we need to perfect operations around the moon. Let's talk about the communication networks being prepared for Artemis II.
Anna, when the Artemis II crew ventures around the moon next year, they'll be farther from Earth than any humans have traveled since Apollo 17 in 1972. Keeping them connected requires an incredibly sophisticated network of ground stations and satellites.
That's right, Avery. NASA has been building out what's essentially a cosmic communication infrastructure, and the latest updates show that the networks are ready to support the mission. We're talking about the Deep Space Network, the Near Space Network, and even partnerships with commercial satellite operators.
Let's break down what makes this so challenging. When the Orion craft carrying the Artemis II crew swings around the far side of the moon, there's a period where they're completely out of direct line of sight with Earth. No radio signals can reach them directly because the moon itself is in the way.
That's where the tracking and data relay satellites come in. NASA has been upgrading the Deep Space Network, those massive dish antennas in California, Spain, and Australia that communicate with distant spacecraft. These dishes can pick up incredibly faint signals from the Orion capsule even when it's 280,000 miles away.
The redundancy built into the system is impressive too. Multiple ground stations can track Orion simultaneously, ensuring that if one station loses signal due to weather or other issues, others can maintain contact. The crew will never be more than a few minutes without a communication link.
What's particularly interesting is how much bandwidth they'll have. Unlike the Apollo missions, which had relatively limited voice communications, Artemis II will have high-definition video capabilities, allowing mission control and the public to see what the crew sees in real time. Imagine watching HD footage of Earth rising over the lunar horizon as it happens.
That's going to be spectacular, and it's not just about keeping the crew connected for safety, though that's obviously paramount. These communications enable real-time science operations, medical monitoring, and the kind of public engagement that makes these missions so inspiring.
The testing that's been done is extensive, too. NASA has run countless simulations, putting the network through every conceivable scenario, from normal operations to emergency situations. They've verified that commands can be sent and received quickly enough to respond to any issues that might arise.
And this network infrastructure they're building for Artemis will serve missions for decades to come. When we establish a permanent lunar base, when we send astronauts to Mars, these same communication principles and much of the same hardware will be the backbone keeping everyone connected.
It's a reminder that space exploration isn't just about rockets and spacecraft. It's about building the infrastructure to support human presence beyond Earth. Speaking of the moon, there's a beautiful celestial show coming up in February that everyone can enjoy from Earth.
Anna, I love these monthly lunar highlights. February is shaping up to be a great month for lunar watchers, with some beautiful planetary conjunctions and interesting phases to observe.
Absolutely, Avery. Let's walk our listeners through what they can expect. The month kicks off with the moon in a waxing crescent phase, and on February 1st and 2nd, we'll see a lovely conjunction with Venus. If you look to the western sky just after sunset, you'll see the bright crescent moon paired with the brilliant evening star.
Venus is always stunning, and when you add the moon to the picture, it creates one of those scenes that makes even non-astronomers stop and look up. A few days later, on February 4th, the moon will pass near Saturn, giving us another beautiful evening pairing.
The full moon arrives on February 12th, and this one has a particularly evocative traditional name, the snow moon. Various cultures have called it the hunger moon or the storm moon, reflecting the harsh conditions of late winter in the northern hemisphere. Of course, the moon doesn't know what season it is down here, so the name is purely a human cultural addition.
After full phase, the moon starts waning, and this is when morning observers get their treats. On February 17th, early risers can catch the waning gibbous moon near the star Spica in the constellation Virgo. Then on February 20th, the moon makes a close approach to Jupiter, which will still be prominent in the pre-dawn sky.
One of my favorite things to watch is how the moon appears to march across the sky from night to night, visiting different stars and planets. It's like a natural cosmic clock, and you don't need any equipment beyond your eyes to enjoy it, though binoculars definitely enhance the view.
Speaking of binoculars, the waxing crescent phases early in the month are perfect for observing what astronomers call Earthshine. That's when you can see the dark portion of the moon faintly illuminated by sunlight reflecting off Earth. It's this beautiful, ghostly glow that reveals the entire disk.
And for anyone interested in lunar photography, those conjunctions with Venus and Jupiter offer fantastic opportunities. You don't need expensive equipment. Even a smartphone can capture these scenes if you have steady hands or a simple tripod.
The moon's February tour also serves as a nice reminder of celestial mechanics. Every conjunction, every phase we see is the result of the precise dance between the Earth, moon, and sun. The fact that we can predict exactly when these events will occur centuries in advance is a testament to our understanding of orbital dynamics.
Though, mark your calendars, folks. February 1st and 2nd for Venus, February 4th for Saturn, February 12th for the full snow moon, and February 20th for Jupiter. The moon is putting on a world tour, and admission is absolutely free. Now let's wrap up with some fascinating research about the chemistry of life itself.
Anna, one of the most profound questions in science is how life began. And new research is revealing that some of the key ingredients for life might form spontaneously in space without any need for planets or special conditions.
This is absolutely fascinating research, Avery. Scientists have discovered that complex organic molecules, the building blocks of proteins and other biological molecules, can form in the harsh environment of interstellar space. We're not talking about life itself, but the chemical precursors that life needs.
Right. The study focused on amino acids, which are the fundamental components of proteins. On Earth, we know amino acids can form through biological processes, but this research shows they can also arise through purely chemical reactions in space, in molecular clouds where stars and planets eventually form.
What makes this possible is the chemistry happening on the surfaces of dust grains in these molecular clouds. These grains are coated with ices, frozen water, methane, ammonia, and other simple molecules. When cosmic rays or ultraviolet light hits these ices, it triggers chemical reactions that can build up more complex molecules.
The researchers use laboratory simulations that recreate the conditions in space, extreme cold, vacuum, and radiation. They found that even without any biological input, amino acids and other organic molecules form readily. It's like space is running a giant chemistry experiment, and the products are the ingredients for life.
This has huge implications for astrobiology. If life's building blocks form naturally in space, then they're probably common throughout the galaxy. When new star systems form from these molecular clouds, they inherit these organic molecules. Young planets get seeded with the chemistry they need for life to potentially emerge.
We've actually found evidence supporting this on Earth. Some meteorites, particularly carbonaceous chondrites, contain amino acids and other organic compounds that formed in space before the solar system even existed. When these meteorites fall to Earth, they deliver this prebiotic chemistry.
It raises an interesting question about the origin of life on Earth. Did life arise entirely from scratch using molecules made here, or did it get a head start from organic compounds delivered by comets and asteroids? The answer might be both, a combination of homegrown chemistry and cosmic delivery.
And when we search for life on other worlds, Mars, Europa, Enceladus, exoplanets, knowing that the basic ingredients are probably already there makes the question shift from, could light's chemistry exist there, to did conditions allow that chemistry to become biology?
The research also highlights how interconnected everything in the universe is. The same processes that create stars and planets also create the molecules necessary for life. We're literally made of stardust, but we're also made of chemistry that happens between the stars.
It's humbling and inspiring at the same time. The universe isn't just capable of creating stars and galaxies. It's also a place where the precursors to life form naturally, waiting for the right conditions to spark something extraordinary.
Which brings us full circle to why we explore. Every mission, every observation, every discovery adds to our understanding not just of the universe, but our place in it and the processes that made us possible.
What a journey we've taken today, Anna. From explosive volcanism on Io to the chemistry of life forming in the depths of space. It's been a packed episode.
It really has, Avery. We've covered groundbreaking propulsion technology, ancient Martian beaches, cutting-edge communications for Artemis, and a beautiful lunar tour to look forward to. If today's episode shows us anything, it's that the universe never stops surprising us.
Before we sign off, a quick reminder that you can find all the links to the stories we discussed today in our show notes. And if you enjoyed this episode, please share it with someone who loves space as much as you do.
You can find us on all major podcast platforms, and we're also on YouTube if you prefer to watch. We're at Astro Daily Pod on social media, and you can visit our website at astronomydaily.io for articles, transcripts, and more.